Hey, good evening. Welcome to Meteorology Lab. We are still devoid of storms here in the southern plains, but there is some action up there in the Chicago area this evening. Taking a look at the surface chart. Let's check that out. There we go. Got a weak frontal system up there, right around Chicago. Cold front extending down into Missouri, around Kansas there, and looks like a little bit of a warm front there in the Indiana area. Overall, the pattern's pretty weak across the U.S., and then we have this little outgoing high pressure area across the eastern U.S. As far as that thunderstorm activity there in the Chicago area, there's a look at the surface map. Hang on just a moment here. We can see dew points are up near 60 degrees there in Illinois. And where they're doing cotton, or not cotton, but where they have cornfields, irrigation bringing that dew point up to even higher numbers there around the Joliet area. So where's that front? Well, I think we've got a fairly strong one further up north. So I think the primary front is going to be up near the top. See, it looks something like that. You can see some very cold temperatures there along the lake. But this looks to be pretty good thermal boundary right there in upper Michigan. And then we can definitely see that cold front extending down into Missouri. And let me shut off the air conditioner. Hold on. All right. Any other thermal boundaries further south? I don't really see anything. There is a bit of a difference in the wind speed in this region. Wind's a lot stronger down there in central Indiana, so that might clue me into maybe some sort of boundary right through this area here. Anyway, those are a couple of features to look at and what the storms actually look like. Let's go check that out here. This is the SPC mesoanalysis, and that shows a quasi-linear convective system there, all the way from Springfield, Illinois, northeast towards Michigan. And let's see what's controlling that system at the upper levels. We'll go up to 250 millibars. You can see a very well-developed trough there across the western Midwest region. The flow is still mostly anticyclonic across the western and central U.S., and these waves are just kind of embedded in that flow there. Got some very fast flow off in the Pacific, and that could change the pattern here coming up in a few days. All right, let's go down to 700 millibars. You can see we're pretty well capped here in the Texas region. Cap quite a bit weaker there in Illinois, 4 degrees Celsius at 700 millibars. And let's go down to 850. We've still got a lot of dry air in Texas. Those dew points running -6 at Corpus Christi and at Fort Worth. And the only place we can find any decent moisture is going to be Del Rio and Monterey, and maybe Brownsville. So we're kind of hurting as far as moisture depth. The actual moisture content itself, we can look at the surface chart for that. And yeah, dew points are a little bit depressed there, mid-50s across much of Texas. And I don't see any 60s except in the Corpus Christi and Brownsville area. And then the large-scale chart looks like this here. We can see that strong cold front up there in Ontario coming southward. Pretty good push of cold air towards Thunder Bay and Winnipeg. Looks like a pretty strong cold front up there in the Hudson Bay area. And here's our Midwest region front there in Michigan. So we do have some southerly flow there in Texas. but due to this ridging, and we can see it in the thermal field here, that's kind of bearing out that ridging there, and that's helping to keep things suppressed. It keeps the lee side troughing kind of shut down and keeps the dry line from coming together. So if we look at the surface chart, I don't see a very clear dry line here. We just go gradually from 20s up to 40s and then 50s. So you could probably make a case of a weak one, maybe something like that right there, but I don't see a very well-defined boundary right now. So that kind of shows you the importance of having upper-level forcing really bringing things together there in the southern plains. Okay, satellite imagery. Got a few storms up there in the Goodland area. So the capping is not keeping things totally shut down. Looks like a system coming through the Colorado, New Mexico area, and of course out in Illinois. We can see those storms out in that area. And I've got a closer look at that. Let's check this out. This is a 50-frame image. It's going to take a few seconds to load here. But this starts at about 4 o'clock this afternoon. And you can see that line coming together in northeast Illinois. So Chicago is located about right there. Milwaukee further up the coast. And we just see all those cells come together as a QLCS. Let me take a look at the chat, see what we have going on this evening. David Lumbert reporting 84 there in Maumelle, Arkansas. David Moore, 90 degrees in northwest Texas. Sue M is here, and Ron Chalfant, 85 today. Ryan Toomey's down there in Florida reporting hot and humid and high 80s. Got Carl Burkhoff here and Shirley Keast reporting 48 in Minnesota. Rainy again. Fun with Tech is here, and Jeff Krob reporting pleasantly cool weather in Maryland. We have Burl H. and Jeff Krob, Michelle Curlin, stormy in Chicago. Adam Davis passed his capstone final. Good to hear that. Willie Greenway checking in from Georgia. Andrew Hotchkiss. And let's see, who else do we got? Mike R., of course, there in California. High wind warning in effect along the west coast, gradients getting really tight there. Mr. Manlett reporting 29 in Rockford under sunny skies. Cayo Delphi is also here, and Erica Baker, Coffeyville, 82 degrees there. And Thomas Copeland. So you can see initially these cells out there start out kind of discrete. If we run this back, you can only see 2 primary cells, maybe 3. There they are, and maybe some weaker cells up in the Milwaukee area. This is good imagery. You can even see the flanking line on these storms. Let me bring back my monitor here. Hang on a second. Okay, there we go. And then as we go on, this is a very common occurrence along cold fronts. Everything lines out, and then by about 7 o'clock Central, it's almost a continuous line up and down the coast there. But speaking about lines, of course, our special feature. Yeah, this is our coverage of journals, and let's see what we're looking at tonight. We've got part 2 of convective modes for significant severe thunderstorms. And this covers some of the parameters. And this is by Rich Thompson, Brian Smith, Jeremy Grams, Andrew Dean, and Chris Broyles there from SPC, and INSEP, or no, that's all SPC right there. So anyway, they looked at 22,900 events, and you can find this paper in Weather and Forecasting, October of 2012. Now, with a limited time, I didn't really have a chance to complete this. I got maybe 2/3 of the way through, but I can show you some of the key points. Let me zoom in on this. So what do we have here? We've got a plot of most unstable Cape, or MU Cape, and then we've got the different categories of tornado-producing storms. So we can see that tornadoes occur through kind of a broad range there, anywhere from 500 Capes all the way up to 2,800. And these values are pretty common on severe weather days, so Cape by itself is not that great of a indicator there of severe weather. So let me hit on some of the key points here. Show you a few of the points that I found here. This is a mixed layer LCL. And of course LCL is proportional to humidity. I should say inversely proportional. So the higher the humidity, the lower the LCL. And this has been found to be a pretty good predictor of significant tornadoes. And so for the discrete supercells, which is over here, we've got three classes of tornado activity. One is non-tornadic. That's just the severe weather and hail, or the winds and hail. And then here we have the weak tornadoes, and then here we have EF2 and above. And then we've got similar classifications over here for the squall lines. So this is non-tornadic, this is EF0, and then we have EF2 and above. So we find that there's a definite correlation between low LCLs and large tornadoes, strong tornadoes. That's particularly true here with the discrete supercells, not so much with the linear storms. It's very little discrimination, very weak. And that's probably indicating that these linear storms tend to form in humid environments there, like very humid. If we go to convective inhibition, 200 is going to be about a strong cap. Anything above, up in this area, this is a very strong cap. These here would be moderate capping, and then we would have weak capping down at the bottom right here. So this is a scale here of convective inhibition. And it's interesting, we find that the tornado-producing storms are associated with somewhat weak or weak to moderate capping. The moderate to strong capping tends to be associated with linear storms and non-tornadic events. So yeah, most of the tornadoes with discrete storms, they fall between about 20 to 60 there as far as convective inhibition. Here we look at bulk wind difference, which is simply the vector difference between the 0 and 6 kilometer winds. And that's with the gray boxes. And then we have effective bulk wind difference, which considers the entire storm there. And let me grab that definition for the effective bulk wind difference. I'd rather have you guys waiting for a few seconds than for me to pass on inaccurate information. So yeah, let me bring that up here, put that off to the side. Yeah, it's defined at the bottom by the most unstable parcel, and at the top by the equilibrium level there. So that's kind of an effect there. It's kind of trying to simulate the entire depth of the storm by what the sounding shows. So what we find with this is that there's pretty good differentiation here between non-tornadic and tornadic environments, especially mostly the significant ones right there. So non-tornadic and strong tornadic events. The strong tornadoes do tend to form in much higher values of shear there. Sorry, I'm just going back and referring to my notes here. And let me go to the next one. This is going to be the 0th or 1 kilometer storm altificity. And what we see here is a little bit better differentiation between the different types there. And you can see the representative values there. And what we're seeing here is the shaded boxes. Those are going to be your 0th or 1 kilometer SRH, and then our effective SRH is the black overlays. And effective SRH is, I'm trying not to make this too complicated here, but hang on a second, let me grab my note here. Yeah, the effective inflow layer is defined by a layer where the CAPE is in excess of 100 joules per kilogram, and the convective inhibition is less than 250 there. So that kind of gives you a good sample of the inflow going into the storm. And what we see here is that with the discrete supercells, there's very good discrimination between the non-tornadic events and the strong tornado events. And that threshold there is about 200 meters per second squared there. Hang on a second. Bulk wind difference. I'm trying to see if there's anything else we want to cover here. Yeah, this is pretty good here. This is significant tornado potential. This is basically your STP. So the one that's being used right now is the new effective layer STP, and that's the black overlays. And this samples the values that we see with non-tornadic versus all the tornadic events. So, yeah, the tornadic events, they pretty much fall below a value of 1. And just about all of the strong tornadoes, they are above 1. Only a very small, only about 25% of the strong tornadoes, they fall below a value of 1. So that's a pretty good indicator, and you've probably seen this on Sharpie. This looks at the different intensities of tornado. So most of the strong tornadoes, they tend to occur with values of about 10. And then as you go down the scale, your episodes with no tornado activity, but with severe weather, those are going to fall closer to 1 and maybe 2 there. So anyway, that looks at a bunch of climatology, and it's kind of good to look through. So again, that's in Weather and Forecasting, Volume 27, October 2012. So hopefully I didn't confuse you or anything like that. This is kind of a new thing that I started doing, and I'm trying to get used to that and trying to refer to my notes at the same time and keep it from getting too boring there. So I'm trying my best here. So anyway, we'll cover more of that tomorrow, and we'll keep hitting a paper every day. All right, so continuing on, let's go ahead and look at the forecast. I think we're probably about that point where we can start looking ahead. High resolution rapid refresh, that'll kind of give us an update there on the storms there in Chicago. Let me bring my monitor up. Hold on a second. There we go. So what are we going to see in the Midwest for the rest of the night? It looks like the storms are going to push eastward. They're going to be in the Detroit area around midnight, pushing into Toledo and the tail end going through Cincinnati there. So this is a pretty fast-moving system. Overnight it becomes more elevated there, and then we have the cool air sweeping in behind. Let's take a look down in the Oklahoma area. It looks like there's a few showers in that region breaking out. Oh, okay, those get forming up there in Kansas. That's that activity up there around Goodland off the top of the screen up here. So it appears those move east-southeast as an MCS during the evening. So those will be coming up there on Bartlesville, maybe Stillwater, towards dusk, and then the area will be falling apart as it reaches I-44. So let's look at the long term here, starting with the upper air pattern. There's that ridging keeping things shut down on the plains there. With that ridging in place, it's going to be hard to get that lee side troughing going. So it looks like another day of ridging. Meanwhile, the wave moving through the Midwest continues to push east, carrying that MCS with it. By tomorrow, we're going to have this ridging across the plains, probably some very warm temperatures from Amarillo to western Kansas, and then we have the change to cyclonic flow out west. So we start coming under this stronger flow starting Friday. So there's the polar front jet coming out into the Denver area. As we get heating going on during the day, we have stronger flow across the central plains, and then we have this very strong trough developing in Nevada and California. Looks like a very strong jet coming around across the San Joaquin Valley there Friday afternoon. And then it appears that that low just kind of sits there and spins over the weekend. So it's going to be tough getting the dynamics coming out on the plains. They're going to be kind of locked up there in Colorado and Nebraska for a few days. But it looks like by Sunday we're going to start getting under the cyclonic flow. So that right there is the inflection point. East of that we've got the anticyclonic flow, and west of that we've got cyclonic flow. So right near that inflection point, that's where we would find the baroclinic system at the surface. So it looks like it's going to be somewhere in Colorado late Saturday, maybe something like that right there. And then we're going to have to look at the GFS for the rest of it. So we're going to be kind of slow to shift gears here. Let's look at the GFS and see what that has in store. Here's our cold air coming into the Midwest right there. And that's going to push through during the day into the Chicago area. And we'll have a bit of a backdoor front there in Nebraska and South Dakota. Looks like we start getting some cyclogenesis there in Colorado as some of the stronger flow comes out of the west coast. You can see the gradient picking up there in Texas. So we should see the dry line start coming together tomorrow. And let's see what happens on Friday. Looks like that MCS will be moving out of Nebraska into Iowa. And then as the afternoon goes on, looks like a very dynamic pattern out there in Utah and Nevada. So there's our front coming through that area. We've also got that push of cold air from Canada creating this front through Kansas and Colorado. The feed of moisture will be coming up from Texas through Oklahoma and it'll be intersecting that boundary right there around Salina. So maybe a chance of storms there for Friday night around I-135 up towards Salina and Topeka. Then going into Friday, quasi-stationary boundary there in Kansas, so possibly a bit of redevelopment with that moisture coming up to that same area. Looks like upslope flow may get going there in Colorado. Good pattern for that. In fact, there it is right there. And then for Sunday, kind of a stationary front, the same area right there, Kansas and Colorado. And where the moisture intersects that, pretty easy rule of thumb there for forecasting development. And let's see how the soundings look there for Sunday. Well, definitely looks unstable. Sharpie there going for about 3,000 capes. I think it may be overestimating that a bit. This appears to be where the moisture is. I'd probably use a colder temperature there. I would probably want to manually adjust that. So I think the lifted parcel looks a little bit more like that. So we're probably talking about capes around 2,500 to 3,000. But still, the cap there does look definitely breakable. But as you can see, the wind flow, very little shear. We talked about the bulk winds with that study we looked at. In fact, maybe I can refer back to that, and we can take a look at that. 0 through 6 kilometer bulk shear is only about 12 knots there. I don't know what the effective bulk shear is. We would have to look at a computation of that. Let's see, is that on here? Shear 10, surface through 3. Okay, surface through 6, 13. Ineffective shear, yeah, 20. So yeah, 13 to 20. Let's look at that on that diagram. See, this is where I think those journals will help if we can actually apply the knowledge. Let's go back to this here. Let's see, bulk wind difference, that's going to be under... This is why I take notes, so I can refer back to what I need to look at. Figure 8, okay. So yeah, we're Kansas on Sunday, they're going to be in that zone right there. So this is definitely not favorable for severe weather. I mean, it could still happen. You can definitely get hail with strong instability and weak shear, but getting those tornadic storms going, that would be more of a problem there. So it's probably good for the residents of Kansas, but anyway, let's continue with the rest of the forecast. For Monday, things look a little bit more baroclinic there in the Texas Panhandle, forming a little bit of a stable wave there in northwest Oklahoma. Still got the flow coming up from the south, and check the soundings one more time. Again, this is for Monday. Fairly decent moisture. Looks like lots of 60s dew points. Not much capping. I think there's going to be some severe weather. Maybe may not be widespread, but I think it'll be definitely there with that kind of instability. Plus, it's May. And then for Tuesday, looks like a little bit of dry line activity, maybe with that erosion of the cap. So the dry line will probably be more important. And it looks like here we're starting to get some upper dynamics. That's probably some upper forcing coming into the Texas area there. Anyway, yeah, for next week, continued southerly flow. So this is looking a little bit more optimistic compared to what the model looked like yesterday. There is definitely still more cold air up to the north. 18th. On the 18th, we've got a big high up there in Hudson Bay. Driving cold air southwest once again. So the fronts are looking a bit like that right there. And then going into the weekend, looks like another push of cold air coming south. Some strong storms out there in Kansas and Nebraska. Let's take a look at what the moisture is suggesting. That's some decent moisture. Mid-60s dew points, a little bit of capping there. And looks like some pretty good low-level shear. It's about 30 knots there of 0 through 1 kilometer bulk shear. So, assuming that stays on track, we would be looking at some supercells there coming up for Friday the 18th. And continuing on, looks like fronts through the central and southern plains. This system here is going to disrupt the moisture. You can see the flow is starting to come around more easterly, and that'll temporarily shut down the Texas coast if this keeps going there. This is that tropical storm we've been looking at for a while. Coming up on Cuba, Belize, it looks like the models are still persistent with that. And it tracks that up into the New Orleans area. This is 300 hours out, so I would not count on that until we get maybe into the 150 to 200 hour point. Then I would start looking at that a little more carefully. But anyway, it does look like a possibility of a hurricane somewhere in the Gulf of Mexico. And there it is making landfall. And obviously the moisture here is going to be a little bit in question due to the uncertainty with this tropical storm. So anyway, yeah, I think we will be getting a little bit more into more of a stormy weather pattern. Let me take one last look at chat and see how things are going. Reading about the second extreme heat wave, Mike R. there. The Weather Channel says it rained for the first time in the Arctic Circle. I think that's... no, they definitely get rain north of the Arctic Circle. Barrow, they report rain a lot in the observations there. They're usually hovering around the mid to upper 30s this time of year. So maybe they mean it rained for the first time in the North Pole. I'm not sure. Landscape background for digital atmosphere. I think the newer versions may ship with that topography. It's called a planetary map. I'll tell you where to find it at least. Let me go back to that. Yeah, that's going to be under the map window, under add overlay. I'm sorry, import planetary map right there. And at least on my system, I've got a directory called planetary maps. Yeah, that's it right there, planetary. So if you don't have that, let me know and I can probably send you a couple files there. Okay, fun with tech. I appreciate the link there. Just looking through the chat there. Thomas Fortner reported hail in northwestern Iowa. Thunderstorms practically all day. Yeah, congratulations to Mr. Manlet there. And Zalkuda, welcome to the stream. And Carl Berghoff says, remember to like. Okay, for those of you that joined late and missed the journal stuff, the playback should post here in the next 30 minutes to an hour. And I think otherwise that'll probably do it for me there. So let me find my buttons here, get that music going. And I'll be off. All right, thanks for joining, and we'll see you tomorrow. And maybe we'll have a little bit more severe weather to look at. All right, take care. We'll see you.